analyze this question we have here. The question is a bit lengthy, but we are going to take them one after the other. Now let's start. The question reads, two elements represented as X and Y have atomic number 9 and 12 respectively, right? Respectively. Now, what is the question? Question 1 says, write out the electronic configuration of X using SPDF notation. Question 2, write out the electronic configuration of Y using the KLMN notation. That is the shell electronic configuration. Question 3, what group does Y belong to in the periodic table? And lastly, we are asked, write the formula of the compound formed between X and Y. All right, we have 4 questions here. Let's put them out. First of all, the elements are unknown, X and Y. The atomic number is 9 and 12 respectively. Question 1, we are asked to write the SPDF electronic configuration, SPDF configuration of X, right? Question 2, we are asked to write the shell configuration of Y. Number 3, we are asked what group does Y belong to, right? Group of Y in the periodic table. And lastly, we are asked to write the formula between X and Y. Now let's take them one after the other. Now the first question talks about electronic configuration. What do we mean by electronic configuration? It is simply the arrangement of electrons in the shell of an atom. Now this arrangement is done in 2 different ways. We have the shell configuration, also known as the KLMN notation, and the SPDF configuration, also known as the orbital or the subshell configuration, right? So the shell is different from the subshell, right? One of them is just the outermost one, and the other is the shell that is inside of the shell. I did a video concerning electronic configuration, so you have to check that video out in order to understand SPDF and shell electronic configuration. Now, first of all, let's write configuration of X. X has 9 electrons because it is neutral, right? It has atomic number of 9. It is neutral, also saying that it has 9 electrons. Now, let's write, there's a formula I normally use in order to write SPDF notation. This is what I normally do. I draw a chart like this. P, 3S, 3P, 3D, 4S, 4P, 4D, and 4F. All right. Since it's 9 electrons, it's not going to get past this particular chart. Now, I pick them one after the other, right? One after the other. Now, note that S subshell holds maximum of 2 electrons, P subshell holds maximum of 6 electrons, D 10, and F 14 electrons. So, how do we do that? First of all, the electronic configuration of X. First of all, we have to pick one. This is 1S. One shell and shell number 1 and subshell S, right? We place 2 electrons. Placing 2 electrons, how many electrons is left here? 7. So place comma. After 1x, the next man to pick is 2x. So place 2x. So x hold maximum of 2 electrons. So we place 2 electrons here, 2 electrons here. That's 4. Remaining 5 electrons, right? So after 2x, the next thing is 2p. Remember I said p holds a maximum of 6 electrons, right? So this is 4. We are left with 5 electrons. So we can simply place that 5 here because our p holds a maximum of 5 electrons. So 5 plus 2 plus 2, that gives us 9. So this is the SPDF notation electronic configuration of X having 9 electrons. Now the next question, question 2, what is the shell configuration of Y? We are told that Y has atomic number 12, and since it is neutral, it has 12 electrons. Now how do we do that? We place 2 electrons on the first shell. Second shell holds maximum of 8 electrons. Third shell holds maximum of 8 electrons. But since we are talking about just 12 electrons, 2 plus 8 gives us 10. And how many electrons is left? Just 2. We have to place 2 here. So this is the K shell, has 2 electrons, L shell has 8 electrons, and the M shell has 2 electrons. The N shell has no electron, right? Because its capacity does have not gotten up to that, right? So 2K, 8L, and 2M. So this is the KLMN configuration of arranging electron. Now the next question we ask, what group does Y belong to? Remember, in periodic table, groups of an element is being explained using their valence electron, right? So since the valence electron of Y is 2, simply mean that Y belongs to um, group what? Group 2, right? The valence electron, the outermost electron is 2. So Y belongs to group 2. And lastly, if X and Y combine, what is going to be their formula? Now we are going to use valencies in order to solve this particular question. I have also talked about valency in my previous video, right? So you can go and check out that particular video. Now, this is X and this is Y. Atomic number 9 and atomic number 12, right? What is the shell configuration of 9? 2, 7. And um, X rather, and Y is 2, 8, 2. Now, what is the valency of X? Valency simply means the combining power. The combining power of X is +1 because X will rather gain 1 electron than to lose 7 electrons. What about this? The combining power of Y is 2 because Y will rather lose 2 electrons. It is to lose 2 electrons in order to have an octet state than to gain 6 electrons in order to attain octet state. Octet state simply means having 8 electrons in the outermost shell. That of X will gain 1 electrons in order to have a complete shell, 8 shell electron of 8, rather than to lose 7 in order to have the duplet state. So the valency of X is 1, and valency of Y is 2. So these valencies, if these valencies combine, we are using the scissors method in writing the formula. Now, X here, we have 2, and Y here, we have 1. So the formula is going to be X2, Y1, or you can just simply write Y. Right? So the formula is X2, Y. Have a nice day. If you enjoy watching this video, make sure you subscribe to this page. Thank you and bye for now.